In many ways, oxy-fuel welding is similar to some types of arc welding. The gas torch is manipulated much the same as a welding gun is moved in specific patterns for TIG welding. But there are some important differences. As you saw in the last program, setting up an oxy-fuel welding station involves a number of important steps. In this program, you'll prepare to weld by looking at differences in torch tips, learning how to adjust the flame, and finally observing how to perform some basic welding exercises with an oxyacetylene welding torch. At the end of any oxy-fuel welding torch, there is a removable tip. The tip has an opening through which oxygen and fuel enter the flame. The size of the opening determines how much heat the torch will produce. Unfortunately, no standard identification system exists to help you determine the appropriate size welding tip for a particular job. Each manufacturer uses its own identification system. A tip with a relatively small opening can be longer and wider than one with a large opening from a different manufacturer. This can make selecting the correct size tip a problem if you use torches manufactured by different companies. The best way to select the correct tip is to refer to the tip chart supplied by the manufacturer. If a chart is not available, you can use a tip cleaner set to give you an idea of the size of the tip opening. Selecting the correct size tip for your job is important because if your tip is too large for the job, you'll burn holes in the metal. And if your tip is too small, it won't generate enough heat to melt the metal. In addition to the size of the opening, torch tips are also designed for specific oxygen and fuel pressures. Older systems required much higher oxygen pressure than acetylene pressure. These low-pressure acetylene system tips were known as injector tips. Most tips today are designed to handle oxygen and acetylene at the same pressure. These tips are called balanced pressure tips. Now, with the oxy-fuel setup complete and the appropriate tip on the torch, let's look at how to ignite the torch. Put on your welding gloves and goggles. Use only gas welding goggles. Sunglasses will not adequately protect your eyes. Turn on the acetylene torch valve. You only have to turn this valve until you can hear the gas flowing. Only the acetylene fuel should be flowing through the torch. Never light the acetylene with the oxygen flowing. With the oxygen on, you cannot determine the safe flow rate for the acetylene. Hold the striker at an angle near the end of the tip. Do not cover the tip end with the striker. Light the acetylene. When low-pressure acetylene burns, it creates considerable smoke. This is normal. With the acetylene burning, increase the acetylene flow until the flame burns without smoking. This is the minimum safe flow rate for the acetylene. The maximum flow rate occurs just before the flame lifts off of the tip and will not return even when oxygen is added. Usually, it's best just to turn on enough acetylene to stop the smoke. Sometimes, with the acetylene flow rate turned up above this base level, new welders may experience some difficulty in keeping the flame settled on the tip as they begin turning on the oxygen. Now, open the oxygen torch valve slowly. Turning it on quickly may result in the flame being blown out. As the oxygen mixes with the acetylene, it produces a bright yellow flame. This yellow flame is an indication that there is too much acetylene in the mixture. A flame fueled by an excessive amount of acetylene is called a carbonizing flame. As the oxygen flow increases, the bright flame will begin turning blue. Increase the oxygen flow until the light blue feather around the inner cone completely disappears. This flame has the ideal mixture of oxygen and acetylene. It is called a neutral flame. A neutral flame is ideal for most welding, cutting, and brazing. If you continue adding oxygen to the mixture, the inner cone of the flame will decrease in size and become a deeper blue or slightly purplish in color. When the flame has an excessive amount of oxygen, it is called an oxidizing flame. Let's look at the effect of neutral, carbonizing, and oxidizing flames on a molten weld pool. A neutral flame creates a molten weld pool that is very shiny. The flame has no effect on the molten weld metal. A carbonizing flame has excessive acetylene. The weld pool is much wider and has a crusty material floating on the surface. Small sparks are noticeable. A carbonizing flame burns at a lower temperature than a neutral flame. It creates harder, more brittle welds. This is because it adds carbon to the metal. The oxidizing flame burns at a higher temperature. It produces an iron oxide foam around the molten weld pool. There is a steady stream of sparks that can be seen flying from the weld pool. Welds made with an oxidizing flame tend to be weak and brittle. Now let's perform a few practice welds. You'll start with a stringer bead on 16-gauge mild steel. There will be no filler metal used. With the torch lit and adjusted, hold the torch at approximately a 45-degree angle in the direction you are welding. This is called a forehand technique. The inner cone should be approximately 1/8 of an inch above the metal. You'll see the surface of the metal quickly begin to melt. Slowly move the torch in a circular pattern to establish a weld pool approximately 1/4 of an inch in width. Move the torch in a circle along a straight line down the plate surface. If the weld pool begins to shrink, slow down your travel. If the weld pool size gets too large, speed up your rate of travel. Raising or lowering the flame height above the plate will also affect the weld bead size, so try to keep the torch height uniform as you progress along the plate. Repeat the stringer bead exercise until you're able to produce consistent welds. Now let's try a stringer bead with filler metal. You'll be using 16-gauge mild steel and a 3/32 inch diameter RG45 gas welding rod. Find a comfortable position. Hold the torch in one hand and the filler metal in the other. Make sure you have a full range of movement the entire length of the practice plate. Hold the torch at a 45-degree angle with the inner flame approximately 1/8 of an inch above the metal surface. Hold the flame in one place until the molten weld pool begins to form. Now move the torch in a circular pattern until the weld pool grows to approximately 1/4 of an inch in width. Now you're going to add the filler metal into the weld pool by dipping the tip into the leading edge of the molten weld pool. Bring the tip of the rod into the weld quickly and move it a short distance back. This will prevent the flame from melting the end of the rod before it's dipped into the molten weld pool. As the weld progresses along the plate, you will need to feed the filler metal through your fingers so your hand does not get too close to the flame. The easiest way to reposition your hand on the filler metal is to briefly stop the weld by raising the torch. Hold the torch so the weld remains hot but not molten as you loosen your grip on the filler metal and allow it to slide through your fingers. Re-grip the filler metal, lower the torch, and resume the weld. As your skills improve, you'll learn how to feed the filler metal by moving your fingers along the rod while you continue welding. Adding the filler metal rhythmically as you move the torch in the small circle will increase the uniformity of the weld as it progresses along the plate. Repeat this practice until you are able to make weld beads the entire length of the practice plate that are uniform in width and reinforcement. Now let's practice tack welds on a butt joint. A tack weld is simply a small weld produced at several points along the joint that hold workpieces together. Position the plates together flat on the welding surface. Hold the torch at a 45-degree angle with the flame approximately 1/8 of an inch above the joint surface. As the plates begin to melt, move the torch from side to side as needed so that the molten weld metal is approximately the same size on both plates. Don't allow the molten metal to become too large because surface tension will pull it back away from the joint. This would create a gap in the joint. When the molten pool has been established on both plates, add a small amount of filler metal. Repeat this process on the opposite end and in the middle as required. When using thinner materials, additional tack welds will be required to prevent the joint from becoming distorted as the weld progresses. Now let's try welding a butt joint in the flat position using a properly lit and adjusted oxyacetylene torch, a piece of 3/32 diameter RG45 gas welding rod, and 2 pieces of 16-gauge mild steel that have been tack welded together. Start at the edge of the joint. The weld pool will form quickly. Once the pool has been established, start adding filler metal. Continue adding filler metal to the leading edge of the weld pool as the weld progresses along the joint. Surface tension on the molten weld metal will tend to pull it back away from the joint, leaving a gap in the center if the filler metal is not added to the molten pool quickly enough. If this occurs, add more filler metal until the weld bead unites into a single weld pool. When the weld reaches the opposite end of the plate, it will tend to become larger because there is less surrounding metal to absorb the heat of the torch. To prevent the weld from increasing in size, raise the torch slightly or increase the weld speed. Add enough filler metal to the end of the weld so that it is slightly built up. This will help prevent crater cracking as the weld cools. Now let's weld a lap joint in the horizontal position using 2 pieces of 16-gauge mild steel, a properly lit and adjusted oxyacetylene torch, and a 3/32 diameter RG45 gas welding rod. Begin by placing 1 piece of 16-gauge mild steel flat on the table and overlap it by approximately 1 inch with a second piece of 16-gauge sheet metal. Hold the pieces tightly together so that they can be tack welded. Make a tack weld at both ends and one in the center. When the tack welds are complete, hold the torch at approximately a 45-degree angle in the direction of the weld with the inner cone approximately 1/8 inch above the plate and pointed more towards the base plate. Watch the plates as they heat up and make any necessary adjustments in the torch position so that both plates become molten at about the same time. Once a small molten pool has formed on both plates, add the filler metal so that the molten pool will flow together. Add the filler metal along the leading edge of the molten weld pool on the top plate. Surface tension will pull the molten metal to the center of the weld. If you are not adding the filler metal fast enough, a small notch may begin to form in the top plate as it melts away. Don't chase this notch with your torch. Increasing the rate at which additional filler metal is added can easily fill it. Continue adding the filler metal rhythmically as you progress along the joint. When you reach the end of the joint, add a little additional filler metal before stopping the weld. Cool the joint and examine it for uniformity. Repeat this process as needed until you are able to produce uniform fillet welds in the lap joint. Now let's review the key segments of the program. 1. The best way to select the correct tip is to refer to the tip chart supplied by the manufacturer. If a chart is not available, you can use a tip cleaner set to give you an idea of the size of the tip opening. 2. As the weld progresses along the plate, you will need to feed the filler metal through your fingers so your hand does not get too close to the flame. 3. Adding the filler metal rhythmically as you move the torch in the small circle will increase the uniformity of the weld as it progresses along the plate.